So the length of a vine during a 12-week period is given by a twice differentiable function L, where L, please stop talking, where L of t is measured in feet and t is measured in weeks between 0 and 12 weeks. The graph of L is concave down. That's important later on that same interval. Selected values of the derivative of L are given in the table, and then we know at time 4 the length of the vine is 5. And that also comes in handy later in the problem. But the first part asks us to find the left Riemann sum with 4 intervals that give you that approximate the integral from 2 to 10 of L prime of t dt. So there are 4 intervals according to the table. So find the width of each of those. So there's going to be 4 rectangles. So you guys figure out the width of each of those rectangles. All right, and these are going to be left, wait, let me read it one more time, left Riemann sums. So for the first rectangle, what number am I going to use for the height? The 1 or the 0.08? The 1 that's on the left. All right, and then for the second rectangle, the height should be the 0.8, and then 0.7, and then 0.4. Okay. So the integral from 2 to 10 is basically the width times the height. So the width of the first rectangle is 2, the height is 1. Second, the width is 1, the height is 0.8. Right. Now this is a non-calculator question. There's a couple of questions you can use a calculator on, but neither one of the free response are calculator questions. But these are not hard to do in your head. And same thing on your test. I'm not going to give you anything crazy difficult to do without a calculator. So it looks like it's going to be 2.8 plus 2.9, which is going to be 5.7. And it asks you to indicate the units of measure. It is feet, good, because it was a feet per week and a week. And so when you do the integral, you multiply those together, so weeks cancel out. So it is just going to be feet. Okay, and then B asks, is the approximation in part A an overestimate or an underestimate for that integral? And then we're going to give the reason why. Oh, I should have done, we're going to do the cards before you guys leave today. But one thing you guys know in the cards, like we talk about it all the time. Okay, so the graph of L is concave down. So does that mean L prime? Because this function is L prime. What does that mean about the function? Decreasing. So since L is concave down, and I'm just going to give the interval from 0 to 12. I'm going to do it that way because it's faster. L prime is decreasing. We'll say on that interval. You may or may not remember the rule for left Riemann sums with a decreasing function. If you don't, it's okay. You know how to draw a decreasing function. And then a left Riemann sum, the left side of the rectangle sits on the curve. So is that over or under? Over. Then you would say left Riemann sum over estimate decreasing functions. I put sons instead of sums. I don't think there's anything you can leave out there. Now you could word it a little differently, obviously, but all of those things need to be said for you to give a reason for your answer. Okay, and then for C, we're going to write an expression to find L of 12 using the information in the problem. We're not going to try to give the value because this is a non-calculator part and it's fine. We don't need to give it. So we're going to use that formula we haven't used in a long time. That if you want, hold on. Yeah, if you want L of, I can't remember how we worded it. We'll say A. You do L of B plus the integral, I should know the other way, of B to A of L prime of B dt or whatever. Do y'all remember that formula? We talked about that these two have to match, and then got some weird colors going on up here. And then these two have to match. Of whatever, yeah. Oh, T, yeah, that needs to be T. It's L prime. It looks like a C. So what we want is L of 12. So what do we know? Like, what's our B? What are we given? All of this stuff is L prime, so we can't use that. We need to know L of some value. We know L of 4 is 5. Okay, so to set that up, we would do L of 4 plus the integral. What are my lower and upper limits on my integral? 4 to 12, good. Of L prime of T dt. And I would stop right there. I wouldn't do anything else. If you do other things, it's still going to be right. There's one other thing you can do, and it could still be right. But I wouldn't risk it. I would just stop right there. So I'll tell you, though, the other thing you can do that's right is in the place of L of 4, you could write what L of 4 equals. But again, I would just stop after that first one. Don't do both, just stop. All right, now when we learned all this, the sum stuff, you guys were so good at it. But it's been a while. We had a week off because of snow. It feels like we had something else, but maybe not. But hopefully you guys can still remember it. So for D, that sum is a right Riemann sum with n subintervals of equal length. The limit of this sum, as n goes to infinity, can be interpreted as the definite integral. Express the limit as a definite integral. Okay. So, what do you guys think my lower limit is? It's technically what we used to call A. Is there an A? Do you see it? Like if there was an A inside these parentheses, it would be like a number plus that 10K over N. So if there's no number plus, then what's A? 0. Okay. Now when I subtract my upper and lower limits, what do you guys think I need to get? 10. So what's my upper need to be? 10. Okay. And then what's my function? My function is L prime of t dt. And that's all we have to do. I should have made a card out of that rule. Probably could still do that, but it would be a mouthful. All right. So that's, you'll have a free response question similar to that one, and you get to practice one without me. And then you're going to have one similar to number 2. This is, yes, we're also pretty good at this too. So we have a function of f, but most of the questions are about g. Actually, all of the questions are about g. And g is the accumulation function. So the integral from -3 to x of f of t dt. All right, so if I want to find g of 0, I'm just going to put 0 in for my x. What does that mean for a question like this with a graph? Mm-mm.
From the limit of 0 to
No limit. The area. So we're wanting the area between what two numbers? -3 and 0. Good. So let's look at what we have over here. We have this. We have a trapezoid. So you guys are, you're welcome to do whatever you need to do to find the area of that trapezoid. I'm just going to use the area of a trapezoid formula, but you don't have to. You can make it a triangle and a rectangle. Just do whatever you got to do. But I'm going to add my 2 bases, which are going to be 1 and 2, and take half of that. And multiply by the height. So if you kind of think of a trapezoid up on its side, the height is going to be how many units that is, which is 3. If you wanted to write down what I did, in case you didn't remember, I used the area of a trapezoid formula. Okay, so on all of these problems where g is the accumulation function, then the actual function f is going to be g prime. So I would always write that. Like, I need that to finish this problem, or my brain starts being weird. Because if I took the derivative of both sides of this is exactly what I would get. That f is g prime. What is going to be f prime? G double prime. Okay, I would also do that.
Then what does regular old G equal?
This right here. The accumulation of areas. That's regular old G. Okay, so the second part of this asks us to find G prime of 2. So looking at what we just wrote, what is G prime of 2 going to correlate to in terms of F? Just F of 2. And F of 2 is the value of the function of F when X is 2. So what do y'all think? 1. Good. Okay, and then the last part is G double prime of -1. Yes, which is the same of F prime of -1, which is the slope of the graph when X is -1. Okay, so if you're looking at the graph, X is -1 right here. What's the slope of that line? -1/3. All right. And these last two are cards. Oh, sorry. These actually last 3 are card questions that you guys shoot out the answers. So you have to be able to apply those answers. So B asks, find all the values of X on that interval at which G contains a relative maximum. Okay. Don't forget that this graph is the graph of G prime. So what happens with G prime at a relative maximum?
Positive and negative.
Perfect. So looking at that graph, when does it change from positive to negative? X is 3. Only x3 right here. Positive above the x, negative below. Right, and then it does tell us to justify your answer. So I'm just going to write, just to remind you that F is the graph of G prime. Just a reminder. So I'm going to justify and give the answer at the same time. So G prime changes from positive to negative at x equals 3. Now you can't say it. You can't really just say the graph because you could be talking about the graph of G. So you have to be specific. If you did say F changes, that's also right. For me, it's easier to think about it as G prime. All right. At 2? Because the graph of G prime is positive on both sides of 2. Not talking about increasing and decreasing. Positive is above the x-axis. You're talking about right here? That's positive. Positive above the x-axis, it stays above the x-axis. Okay, now we're not done. So therefore, G, you can't say it, you have to say G attains, or you can say it has a relative maximum there. Or you could say at 3 again if you want to. And again, there's nothing you can leave out. You have to say all those things. Okay, C. Find the open intervals for which G is concave down. So don't forget that this is the graph of G prime. What happens on G prime when G is concave down? Decreasing. So I'm going to write it again. This over here isn't necessary for your answer. It's just to help you remember what to do. So G prime is decreasing on there's two places where G prime is decreasing. What do y'all think? -3 to 0 and oh, what? Sorry, -3 to 1. My bad. -3 to 1 and 2 to -1. Good. Two to 4. Therefore, G is concave down on those intervals. Or you could say there is concave down there. Okay, see if you guys can do D on your own. D doesn't ask you to give a justification, so you can just answer it. So if we have the graph of the derivative of G, what do we look for to find points of inflection on G? Relative max and min. This one has 3. Where are they? Good. Now, if you give an explanation, that's fine, but you don't have to on that one. But you might make yourself a note that it's going to be the relative extrema of G prime. Or you can say relative max and min of G prime.
So you don't even like have to specify.
It just tells you